Okay, again, we're moving through the notes. Again, I want to encourage you. You don't have to watch videos to do this material. If you feel comfortable, moving forward on your own, you should. All right. It's when you get stuck, you need help. And at the beginning, I really say it's. Although Wells sometimes gets some really tedious problems, stuff that I don't even enjoy doing, and I kind of like doing stuff like this, but some of the problems are kind of tedious. There's a point to it, though. He's really trying to point out, maybe there's some patterns, underlying patterns to what we're doing. And I will say that algebra does introduce a tremendous number of patterns, not so much in modern day algebra, but historically algebra, I think, was a lot of pattern recognition, that you saw patterns in things. All right, and mathematics has a lot of patterns in it. Anyway, let's go through this again, real carefully. You got, this is the materials. This whole section is for the materials for exercise 7. Contents, that's you read through it. Examples, that's me. I'm going to be working through it, but you can work through it on your own. You don't have to watch me. And then exercise that you have to work through on your own. This document is being made available to the Prison Mathematics Project participants, and that means that the incarcerated individuals, their mentors, probably security personnel, administrators. Just I don't want this document getting out there. All right, I don't want it to be shared. Right, it will be published at some point in the future. I realize if you're watching these things on YouTube, you might say, I want the document. Well, again, go back and look at those original videos that I put up there, like, about the intro videos about, my goal is to publish it. Again, you can reach out to me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, I'm going to start going through the notes. And not that I want to read them to you, but I will point out that Wells, again, is introducing patterns. All right, now what does he give you? He gives you these quotients. And he says, you should find these by actual division. And you should do division on those things. You'll find out it's true. And then he goes through a bunch of examples. All right? And we're hoping that you paid attention to that. All right? He also mentions something about the remainder theorem. I think it's something that you should read and think about. All right? So, over here, the bottom line is, you might say, what is he trying to tell me over here? Well, let me just, outline that a little bit. He's taken 2x cubed minus 7x squared plus 10x minus 3, and he's dividing it by x minus 2, and he finds out it's 2x squared minus 3x plus 4. That's what he finds out, plus 5 divided by x minus 2. And then what he does, this is about the remainder theorem, he multiplies both sides by x minus 2. And if he did that, what would he get? 2x cubed minus 7x squared plus 10x minus 3, 2x squared minus 3x plus 4 times x minus 2. Again, he's multiplying both sides by x minus 2. And that second term, I'm treating this as a term over here, plus 5. So what does he say? He says there's something interesting about this. He says that f evaluated at 5. I'm sorry, I made a mistake there. F evaluated at 2. Let me have an eraser out. Well, that should be rather easy to do. What is it going to be? Well, if I'm looking at it, it's 2 times 2 cubed minus 7 times 2 squared plus 10 times 2 minus 3. But he goes on to say it's really much simpler than that. The reason that if you're talking about 2, this first term would disappear. And why is that? 2 minus 2 is 0. And that's a factor of that. Plus 5. So he's saying that remainder theorem is a really easy way to determine the evaluation of function at the number 2. All right? Now, granted, you may not agree with that, but it's really not bad. Right? He does mention that with the quotients and the remainders and the divisors and things like that. Talks about factor theorems. It's an important concept. It's one you may want to think about. For example, looking back up here, I know x minus 2 is not a factor of 2x cubed minus 7x squared plus 10x minus 3. I know that for sure. If it were, there'd be a remainder of a 0. All right? So he talks about that. And again, we'd like you to think about that as well. All right? So he also talks about, divisibility rules, something to think about. How does he do that? He really kind of talks about factor theorems. All right? Think about it. Read it. Think. But the point of this over here is after all that thinking, it gets you some other results over here, that you should be ready to do problems. I'm not going to claim it's going to be easy for you. All right? Not going to claim it's going to be easy for you. Reading that can be very difficult. All right? But here's my claim. I'm going to boil it down to kind of simple things over here. Basically simple patterns. All right? And we're talking about these guys over here. All right? So let's take a look at it. And certainly if I were doing that over there, I'd, certainly I'm saying which pattern does it look like? And I would say, looking at what's above over here, it looks like the a cubed minus b cubed divided by a minus b. All right, let me write that down for you. So 27 a cubed minus b cubed divided by 3a minus b. Let me tell you why I believe it's that pattern. This looks like on top 3a cubed minus b cubed, and the bottom is 3a minus b. So it definitely looks like that pattern. And what do they say it's going to be? Well, if you look at it, the big A would be 3a, so this would be what? 9, because I'm using this pattern, a squared. Then it's going to be plus, well, the 3a times b, which is 3ab, plus, again, we're looking at the big B there. The big B is a little b, and that would be the b squared. Now, I realize your assumption said, I'm not at that level where I can recognize a pattern. I'm going to do a division to do that. You can do a division. We wouldn't be opposed to that. All right? Now, someone says, what do you mean you're going to do a division? If you did the division would look like this over here. And I'll write down for you. I find long division, though, to be kind of tedious. Whoops, I made a mistake already. Kind of tedious. I'm not saying it's bad. I'm just saying I find it tedious to do. So what times 3a would match 27a cubed? I would say 9a squared. And what do you get? 27a cubed minus 9a squared b. What do you do now? Subtract. So that would be 9a squared b minus b cubed. Now, if you're struggling with long division, really go back to a prior section and try to master that long division algorithm that we taught you. Let's keep repeating. I'm going to say what times 3a would match 9a squared. I'm going to say plus 3ab. Let's give it a shot. Well, 3 times 3 is 9. A times a is a squared, and we do get a b. Then what do you get? Minus 3ab squared. Now, if you subtract, what do you get? 3ab squared, and drop the place down, minus b cubed. Repeat. What do you get over there? I'm going to say, looking at it, it has to be what? Looks like it has to be b squared, right? So 3a times b squared is 3ab squared. And b squared times minus b is minus b cubed. And yeah, lo and behold, we get a remainder of 0. Are we getting the same result? Of course we are. It would be ridiculous to get another result. All right? So this one says long divide. Let me just go through that with you again. Again, the way it's written over here, I'm changing the signs. I don't like doing that, but that's what most students do. I'm just going to remind you what I would do. X minus 2. And that's divided to 2x cubed minus 7x squared plus 10x minus 3. Well, let's see. What times x would be 2x cubed? I'm going to say 2x squared. What do you get? 2x cubed minus 4x squared. Again, I want to point over here, they change the signs and combine. There's nothing wrong with that. I'm not saying it's wrong. I'm just going to subtract. What do you get? Minus 3x squared. I drop my places down, and I'm the kind of person who likes to drop all the places down. You notice over here, they drop the places down, but not all of them. I like to drop everything down. Let's keep going. What times x would be minus 3x squared? I'm going to say minus 3x. What do you get there? Minus 3x squared plus 6x. What are you going to do now? Subtract. What do you get? 4x minus 3. Let's keep going. What times x would be 4x? Boy, they really do pick nice numbers, don't they? Plus 4. What do you get? 4x. And 4 times minus 2 is minus 8. And you subtract. And what would you get? You get 5. So let me write down the answer the way it should be written down. So 2x cubed minus 7x squared plus 10x minus 3 divided by x minus 2 would be equal to 2x squared minus 3x plus 4 plus, I didn't divide, 5 by x minus 2. Now someone's going to say, could you divide 5 by x minus 2? And the answer is a remarkable yes, it can be done. All right, so I'm going to claim, if you're looking at my notes, I do write that down for you. All right, then I talk about the remainder theorem. Let me tell you what I did over here. I multiply both sides by x minus 2, and you get this over here. Then what do they claim? They claim if you put x equals 2 into that, you would get 5. What's interesting about that over there, it should be 5. And the reason for that, if you put x equals 2 into that expression, this would become 0 over here. And 0 times anything is going to be 0, and then we get 0 plus 5. No surprise there. They do remind you, and this is me reminding you of what's in the text about the division algorithm for those things that look like that pattern over there. All right? So this one, again, says long divide, and there's a reason for that. They want you to practice that long division, and I'll do one at a time for you. All right? So let me do the first one. And again, this is something to do with what's presented above. And that's dividing into A4 minus B4. Well, I'm saying if I look at that, and again, this is a pattern. You could write the answer down without dividing. If I can say A cubed, what do you get? A4 plus A cubed B. Subtract, that would be minus A cubed B. And again, I like to drop the places down. Repeat, that would be minus A squared B. Let's do it. What do you get? Minus A cubed B minus, let's take a look at that, A squared B squared. Again, we'll look at the key in a second. What do you get over there? I'll subtract. What do you get? A squared B squared minus B4. Keep going. Well, what do you do over here? This would be plus A B squared. I hope you see a pattern over here. A squared, B squared, and then what do you get? Plus A B cubed. Let's subtract. What do you get? Minus A B cubed minus B4. Wow, this is getting tough, isn't it? So what do you get there? Let's take a look. I guess I have to do minus, what do you get? Let's see, B cubed, right? So what do you get? You get minus AB cubed, and that would be what? Minus B4. What's the remainder there? 0. So I'm going to claim that's a division they asked me to do, and I've done it. Now, what I want to do is make sure you know that's listed for you here. All right? You can check it, and we'll say A cubed minus A squared B plus AB squared minus B cubed. Right? These are nice patterns, by the way. Let me do the next one for you. Again, I know it's difficult, but I'll write it down for you. The next one says, you know, divide A4 minus B4 by A minus B. I'll write that down for you. And that goes into A4 minus B4. Well, let's take a look. Let's see, what times A would be A4? That would be A cubed, right? What do you get there? A4 minus A cubed B. Let's subtract. A cubed B minus B4. Let's keep going. What would you get over there? Plus A squared B. What does that give you? A cubed B minus A squared B squared. What do you get there? Minus, I'm sorry, not minus. I made a mistake there. I daydreaming again. I wake myself up when I'm daydreaming now. It gives me A squared B squared minus B4. Let's keep going. What do you get next? Let's see. I'd have to do what? Plus AB squared. What does that give me? A squared B squared minus AB cubed. A little line there. Subtract. What do you get? A B cubed minus B4. Now what do? I'm going to multiply by b cubed. What do you get? ab cubed minus b4. And lo and behold, another division producing no remainder. The remainder is 0 in both cases, all right? So I'm going to look at the answer. And someone says, why do you do that? I don't know. Maybe I made a mistake. And look at it. It's right over here. A cubed. Make sure you're looking at the thing I'm looking at. A squared b, ab squared minus, plus b cubed. It looks pretty good, okay? So I did 2, and certainly we'd say that you can do the other 2, but I'm starting to think that maybe these are a lot easier than I could ever imagine, all right? Like, I don't think I really want to divide now. I think I've got the feel for it, all right? It says, what do you mean you got the feel for it? Well, we just did something. And what do we do? And I'll point this out to you. We did this one. And we did, let's see, I did that. And I did this one too, right? Now what are they asking me to do? They're asking me to do these. Well, I think I'm ready to do it. And I think I'm ready to write it down really quickly without writing this long division thing down. So I want to write this over here. Again, I'll put a little line over here. Make sure you know I'm not doing the same problem twice. I'm going to take a5 minus b5 and divide it by a plus b. Well, I'm going to say it kind of looks like this one over here. What am I expecting? I'm expecting to see a4 minus, we reduce the a's exponent by 1, a cubed. We'll check later, b. Then what I'm going to say, plus a squared, b squared. You notice the power of the a's are going down and the powers of b's are going up. Okay, let's keep going. And then what do you get? Minus ab cubed plus, well, now there's no a's, but I got a b4. Let's look. All right, I'm looking. I'm looking at this now. a4 minus a cubed b plus a squared b squared minus ab cubed plus b4. Looking good. All right, let's do the next one. And the next one's going to be, I'll write it down for you. It's a5 minus b5 over a minus b. I'm going to say it looks like this second guy I just did. I just did that. And what am I expecting? I'm expecting this. a4, a cubed b plus a squared b squared plus a b cubed plus b4. And someone says, well, you didn't do the long division. Yeah, I did. I just did it quickly. Right? I didn't do this stuff over here. I'm doing something where I'm seeing a pattern. Now, you may not remember the pattern. You can always go back to long division. Are we getting what they said we should get? Yeah, we're getting exactly what they expected to get. All right? Let's keep going. They talk about, proving this thing through mathematical induction. And again, you may want to think about that, but right now I wouldn't think too hard about that. I think about you see a pattern. All right? So let me see if I can figure that out. All right? By looking at this one over here. Without doing a long division, by the way. And again, we're considering that maybe we can do this without doing too much by simply knowing a pattern. So if someone says, I don't remember what pattern you're talking about, it has something to do with this up over here. And what am I doing? I want to point out what I'm doing. The powers on top, it's minus, and the things on the bottom are minus. So I'm looking at, a pretty simple pattern. I'm looking at these patterns. All right? I think I'm ready. And we'll check. Maybe I shouldn't put the answer there so quickly. A6 plus A5 B plus A4 B squared. I'm going to make one mention about this. It appears that every term, the sum of the exponents is 6. All right, let's go to the next one. A3 B3 plus A2 B4 plus A B5 plus B6. Very nice pattern, by the way. Let's take a look, see if they agree with my answer. I'm looking for terms. Looking good. All right. So let's try this one, a little different. It's really not that different. So I'm going to write the top down as 2x to the 4 minus 3 to the 4 all over 2x plus 3. All right, I want to look at the top. And I want to make sure you know what we're doing over here. And really what I'm doing, I'm kind of saying that it kind of looks like these patterns. It kind of looks like those. And they're alternating, aren't they? So we're going to look at it. And I'll write this down. You can be very careful. And I'll write down one at a time. All right? So I'm going to say, we'll clean it up later too. 2x cubed minus 2x squared 1/3 plus 2x to the first power 3 squared. Let me point at every single term. The sum of the exponents here is 1, exponent there is going to be 3. What comes next? Well, there'll be no 2x's, but there'll be 3 factors of 3. I'm going to clean it up for you, and then we'll look at the key. All right? First term, 8x cubed minus, that would be 4 times 3, which is 12x squared, plus, well, it's going to be 9 times 2, which is 18x, plus 27. Again, I can't say look at the key. If you're not seeing it, something's got to be wrong, including your daydreaming and you wrote the wrong thing down. I made a mistake. And I'm going to fess up to it. And yeah, maybe daydreaming, all right? Let me go back over here. And I want to point out, it said alternating signs, remember? Alternating signs. So I'm going to say, this can't be right. It's got to be alternating. Plus, minus, plus, minus. Let me go back to that. I corrected it. Oops, I didn't correct this one. Looking back up here, I'll show you what I mean by that. I'm looking at alternating signs. Plus, minus, right? Plus, minus, plus. They're alternating, all right? Going back and forth. Sorry about that. I was daydreaming. All right. Oh, I think it's over. Good. What do you have to do? Do it on your own. You got to get busy. So get through this. I know it's a lot of work. I go through a variety of techniques with you. You decide what works best for you. All right. I always say it works best for everyone, particularly if you enjoy what you're doing. You'll eventually get to this section of the notes. Let me just remind you, this is the section on CAS, a computer algebra system. And I can't sometimes you really want to take a look at it, right? If you have the option to look at it. And that means go to this website over here, either download the application or the interactive web-based application, and try to put some of this code in over here and see what it's doing. All right. Now, again, not to memorize, just to, reason through it. That's all we're asking you to do. Just reason through it. All right. Now, if you need to reach out to me for whatever reason, my email address is Bannon. That's Bannon, B as in boy, ANNON.US. Okay, let me just tell you one other thing. I know for some students watching this, it's torture for them. So, I would say if you're watching and can't do it, it's torture. Go back to an earlier section. Try to master the material. All right? Now, it can't hurt to watch little pieces of the video. Maybe streaming this whole thing's in one shot might be a bad idea for some students. But again, use things as you see fit. All right? Thank you for paying attention, though. See you soon.